Hey guys, really nice to see you here. How are you doing?
Hey, hey.
Hello.
Yeah, so Timur is a Java developer from Одноклассники, and he's gonna be an expert in this track today for this workshop. So all questions and all technical speeches is gonna be from him. And now I'm gonna give him time to talk a little bit more about the workshop, and then guys, just let's do it.
Thanks, Vale. It's a pleasure to be here at Joker. Well, I can say that I wish we could have an offline conference, but obviously not in 2020. Probably the next year we're going to be a little bit more lucky, but now we are going to have a workshop. Well, workshop is a perfect beginning for the conference. I believe in this. And well, workshops are usually not a frequent guest on the menu of Joker, but when they are on the program, you know that it can be a truly gem. And talking about the technology, GraalVM, it's been already on the stage for a while, and usually there are a couple of talks even on Joker about the GraalVM technology, and one of my favorite talks during the last Joker conference, offline Joker, was a talk by Thomas. And well, workshop, it's not a simple talk. It offers much more. It can give a good outlook to the technology, and it can show all the benefits. You know, GraalVM is getting more and more popular, and such features like shiny new just-in-time compiler and ability to make native images with a smaller footprint is really promising. Well, I'm not going to spoil anymore. Thomas, Oleg, let's get started.
Thank you. Excellent. Thank you for the introduction. Yes, we're happy to be here at Joker conference. It's always like such a great audience here. And this time around, we will do a little bit more workshop style, where at first I'm gonna give a short introduction, but then we go right into the workshop with Oleg doing some live coding, and you're encouraged to do this as well. So basically, follow Oleg's instructions and get some practical benefit out of this session. So while I'm presenting a short introduction to GraalVM, if you haven't done so yet, please install and download and install the GraalVM binaries in the latest version, which is 20.3. And with native image, because in this workshop we're going to focus a lot on GraalVM, Java, JIT compilation, and on native image. Yeah, so if you haven't done so yet, please take the time while I'm presenting to download and install GraalVM itself. And I will just give a short introduction on where the technology stands. As mentioned in the introduction, the technology already is around for some time, so it's getting more mature nowadays. So it's now really getting ready for production use. And generally, GraalVM is a technology that is for a lot of different languages. So we can run, of course, all of the JVM-based languages on OpenJDK. We can also run other languages like Ruby, Python, or JavaScript in a polyglot fashion. And we can run even static languages like C, C++. Finally, added rather recently is support also for WebAssembly. So even WebAssembly can run on the GraalVM platform. And the special thing about GraalVM is that it can run on OpenJDK, but also other systems. For example, it can run embedded in Node.js, or it can run embedded in the Oracle database, or it can run it standalone as native image. And so when people say the word GraalVM, often they mean only one part of GraalVM. In reality, GraalVM has 3 different main usage scenarios. One is you can use GraalVM as a drop-in replacement for Oracle's Java 8 and Java 11. And in this setup, we just use the JIT mode of GraalVM and it runs your Java application faster. The second scenario is the native image part of GraalVM, where we do the ahead-of-time compilation of Java to create the standalone binaries and low footprint. And the third part is you can use GraalVM to combine languages and to do polyglot programming. And it's important that when people say the word GraalVM, GraalVM really is these 3 things. It's not one of these things. It can do all of the 3 things, and depending on what you're currently most interested in, you would use one part of GraalVM. In this workshop, we're gonna focus mostly on the ahead-of-time compilation for Java to create standalone binaries and low footprint for Java, and we're gonna show a little bit of Java. And maybe in the end of the workshop, if we still have time, we will also cover polyglot.
Yes, so perfect. Sorry, Timur, for interrupt you, and let's continue the workshop. Yeah, and sorry for the problems with connection, so let's go.
Right, no worries. Yes, so as I mentioned, so you choose your AOT versus JIT based on the use case. So if you care about startup, memory footprint, or packaging size, then you would typically choose the ahead-of-time compiled mode. And if you care about peak throughput and maximum latency of your application, you would choose the JIT mode. And in GraalVM in general, we are constantly improving performance. We have here a little graph that shows how we are squeezing out a few percentage of performance almost each release. This is on a very wide variety of benchmarks, and this is for the GraalVM releases 19.3, 21, 22, 23. So our performance work really is a game where we are squeezing out 1% here, 1% there, but over time it really adds up and makes GraalVM a very, very fast virtual machine. And in terms of addressing with ahead-of-time compiled mode, the peak throughput and max latency, we very recently introduced a new garbage collection option for native image that we will demo also in the workshop, which is the G1 garbage collector option, where you can use a G1 garbage collector style in your native image. And the second thing to address the peak throughput in native image is to use profile-guided optimizations, where you create a native image that is instrumented, you run some workload on that instrumented binary to get profiles, and then you use those profiles to get an optimized binary. In terms of support, native image is supported by the common microservice frameworks. For example, for Micronaut, we are going to demo Micronaut today, but it's also supported by Helidon and by Quarkus. And there's also great work done by the Spring team at Pivotal to create GraalVM support for Spring applications. And it's progressing very well. And we can only refer to their project page there, where they did great progress in making GraalVM work with Spring. And GraalVM has many different components, so it's sometimes difficult to say which component is like ready, which is not ready, which is like beta, etc. And in terms of production-ready components, the Java execution in both native image and JIT mode is certainly production-ready, and using GraalVM to run JavaScript is also production-ready. Experimental is currently still Ruby, R, and the LLVM toolchain. And some of the visionary steps we're taking is in the area of Python, where we add Python support to native image, and to GraalVM. We add Visual Studio Code plugin currently that helps you with developing GraalVM. And we have a GPU integration project with NVIDIA, WebAssembly support, and an LLVM backend for GraalVM native image. These are kind of more forward-looking projects that are not yet 100% ready. And GraalVM is a big ecosystem, and we are very happy to see each year even more people join the ecosystem. But we now have the GraalVM advisory board with many great companies on the board. And in general, we are happy to see this ecosystem grow, because if it grows, then you can use more and more combinations of languages, GraalVM utilities, and GraalVM embeddings for your own use cases. And so GraalVM is ready for production use, certainly, and some of this is what we're going to now demonstrate in the workshop part of this session, where Oleg will do the live coding. And yeah, remember, this is a workshop, this is interactive, so if you have any questions for me or for Oleg, we are happy to answer them also in between. And with this, I give over to Oleg. Oleg, I cannot hear you yet. Maybe others can, but I cannot hear. Maybe refresh, Oleg.
My input is working.
That works now.
Very good, very good. I'm back now. Very happy to be here. I really hope that by now I could be there in person with all of you people, right? And unfortunately not. And unfortunately, I'm even stuck further in a self-isolation in a hotel. So excuse me for my internet connection troubles if they happen further as well. But without further ado, let's start with our here. So it's a workshop, and as a workshop, when we were trying to prepare this, we thought what would be the most beneficial for you, right? This should be an interactive session, right? This should be an opportunity for you to do to try some experiments with GraalVM yourself, right? This should be an opportunity where it's a longer session, right? It's almost 3 hours. So I would be absolutely thrilled if you would try GraalVM, if you would try to follow along with the exercises that we prepared, and then you would ask questions, right? And it's completely, we have Timur there as an expert monitoring the chat. So if you have any questions, you can ask them immediately. And I'm doing the exercises myself here, so you can just look at how I handle them. Hopefully it will be rather smooth, or you can follow along. Right, but the main benefit of this would be if you actually try GraalVM, and then you would get a feeling how it works and how easy you can maybe apply to your projects, whether to evaluate for like this project, pet projects that you have. You have the instructions. I have the instructions here. So if you want to follow the instructions, you go to the github.com Šelajev workshop, to the README file, the main README file. I'm sure someone will put them in the chat. And I assume at this stage that you have downloaded and installed GraalVM. So I will be doing this, and I will be using my reasonably powerful cloud machine here. So let me make the screen a little bit larger for you, so you can see the font well, right? I will do, what do I have here? This is the Linux machine in the Oracle Cloud. I have a few CPU, I have a few gigabytes of RAM available. So this is the cloud machine that I usually use for myself as a workstation. I have my GraalVM installed there, right? So if I do reach Java, or rather I do Java minus version, I have GraalVM Enterprise Edition 20.3.0 installed. This is a recently released version. I'm using Java 11 based GraalVM distribution. I think all of this should work also for Java 8 based distribution. So if you are using 8 more like commonly for your like work related matters, then you can try that one. But it should work on 11s as well. And there are all the flavors. The most common operating systems are supported, so you can download that for Mac or Windows as well. For this workshop, I would not particularly recommend Windows because some like additional tooling around GraalVM that we're going to use might not be available on Windows out of the box, or it's harder to install. So if you're using Windows and you can either move to a Docker container with Linux environment, or you can move to the Windows Linux subsystem, which should work, and use the Linux distribution, that would be absolutely grand. Right, so I have my GraalVM, I have my native image utility double dash version installed here as well, right? So it's all ready to go. I also have my JavaScript there, Python and other languages. But as Thomas mentioned, we're going to concentrate on the benefits for Java projects or projects written in JVM languages, which we commonly refer in this workshop as Java applications, right? Everything that compiles to the JVM bytecode will be a Java application for the simplicity. Don't tell that to people who develop the languages or other runtimes. Not sure how approved that messaging is. Right, so we're going to get started, right? And I'm going to start with the first exercise here. We're going to build a native image executable out of a sample project, right? And the native images are one of the more interesting parts of the GraalVM that definitely sparks interest in the community. So we're going to start with that, and we're going to continue exploring native images for quite a bit of time, and then move to measuring the performance improvements of running with the JIT. The first exercise here, I wanted just to show how simple it is to build a native image of an application that actually does something meaningful, right? So I picked as my framework, and as Thomas mentioned, there are a number of frameworks which support GraalVM native images as a deployment target. Micronaut is one of them. I personally like Micronaut very much, and it has the command line utility to generate new things. So I'm going to just go and execute my things there, right? So I have my GraalVM installed. I have my Micronaut. I have my Micronaut command line utility installed, right? And I'm going to make an empty directory here, not to mess with any of the previous setups here. So I will do mkdir, and you do Joker, and I will enter that, right? So now we have the clean slate here. We can do whatever we want. And what we're going to do, we're going to create an application here using Micronaut. Right? Very simple. We create an application, we enter the application, and we need to populate the business logic. Our application will be very simple, right? It will compute the prime numbers. So for GraalVM is a runtime, right? So as a runtime, GraalVM runs applications, and it doesn't it's technically is like business logic agnostic, right? It doesn't care that much what your application business logic is because it will run it anyway. So for this workshop, we're going to concentrate on the GraalVM tooling and what it offers, and not on the particular examples and details of the actual code that simulates business logic. So we're going to do this on a very simple application. We're going to generate prime sequences, right? So a prime sequence is a list of longs between the minimum and the maximum element, and they need to be prime. And to check whether the number is prime, we're going to just iterate through this stream and check the divisibility, right? The most straightforward thing ever. So what I'm going to do here, I'm going to take the path to the file, and I'm going to open my favorite editor, and I'm going to edit this file, and I will gonna just put my code inside, right? We save that. We need another file because this is the command line application, which is using Micronaut and Pika CLI as a library to run this application, to make it a fully featured command line application. So we just need to execute and change this main class as well, which actually will run our thing. It's very important, but it's not particularly interesting, right? So we're gonna just 100 double D, delete everything, and just paste the code there. If you're asking yourself, why didn't I just prepare a repository with those two classes there? That's the answer is because I wanted to show you that you can just take a default application, right? And you can run it and you can build it. So it's a Micronaut application, so it's a Gradle application. I'm gonna hit the run. You can build it and you can start from scratch, and the application will run as a native image, which is actually very great. So for quite a bit of time now, I hear here and there some notes or on the internet, people are saying that GraalVM native image is hard to kind of configure for, and this is not true, right? You can take simple sample applications. And if you're doing, you can use GraalVM native image in production without any concerns. Right, so my application is built now. I can show you that it runs. Right, I'm going to use my Java command here, and I'm going to run the jar file. I'm going to pass the parameters. Double. We don't want twice to paste this, right? We want to paste it just once. And I'm going to run it, and it's going to take one iteration, and it's going to limit, as you can see, it's going to limit my sequence at 100, and it's going to do one iteration of this invocation, and it's going to print me some prime numbers between 0 and 100. Very well. So it works, right? It works. It runs as a Java. You can also see this is the compatibility thing of GraalVM. It contains a compatible JDK, so I just run it. Any Java application can be run on GraalVM. Now, to build the native image, I need to execute the native image command. There are a few ways how to do this, right? There are a few ways how I can do this. I can take the jar files and feed them to the native image utility by hand, right? I can call native image and parameters, and then say, this is my jar file, or this is my class path. But Micronaut also features a Gradle plugin that will build native image for me. So I will just execute this, and I hope that you are also executing this as well, or you will get to executing this very soon. And it's going to process your application. So it will take our Java application and create a class list of that and set up everything and initialize some classes there. It will look at what points to what. It will remove the unnecessary code from this application, right? It will limit it only to the classes and methods and fields that are actually in use and strip everything else. And then it will compile all that, and it will write that out into the executable. It will use a little bit of heap to do that. So you can currently see that it's somewhere at like 4 gigabytes, which is not an issue, right? 4 or 5 gigabytes is like 4 or 5 Chrome tabs. And it takes a little bit of time. So around a minute for this application, I think. But it depends on the actual power of the machine where you run this. So now we just wait here for this to finish. It's a small application, so it takes a little bit of time. If you have a larger application, it will take a little bit larger amount of time. But we have been doing a lot of progress and have been doing a lot of research how to kind of limit and contain this time that it is going into building the native images. I expected this to be a little bit faster, but I think 2 minutes. 2 minutes is fine. 2 minutes here, and 6-7 gigabytes. Very well. Right. So we have our application, and I can show you that it actually runs. I can just paste this and do help. My application runs. You can see it starts really fast. It does implement the same logic. So I can do the same thing that I did before, and 1 minus L100, right? It starts really fast. It prints the same numbers because the random, if you look at the code that I showed you, the random instance was pre-initialized with the concrete seed. So every time I get the repeatable results there. You might not want to do this in production, but I just wanted to have the exact repeatable sequence of random bits that will do. And this way I can run the application, right? So now let's explore this file that I have. I will explore the file. This is an executable file. This is an executable file here, the L file that I can run. It is dynamically linked to the and if I use the LD utility here to see what it is linking against, then I can see a number of libraries, right? They're all operating system libraries. Doesn't depend on the JDK. It doesn't depend on the JVM installation here. So I can move it to another location. So you move this. So say here. No, here, right? Move this here. and I have my application here, I can still run it, right? That doesn't, it works the same way, which is very, very excellent. And now I will do, there is no LDD on, I don't know if it's LDD is available on Windows. On Mac OS, I think this invocation is otool, right? -L, something like this, or you can do man otool running this on the Mac inside the Mac OS, not inside like a Linux environment. otool -L, and you will see what it links against on the Mac. I've heard some reports just recently that the native image executables that are built with native image might experience some problems with the quarantine or something, with some defense system of Mac OS. Don't worry if that happens. That is not supposed to happen, but I've heard that people say that it sometimes happens. So if you stumble upon that, just power through. It's probably either quarantine or something. You need a Mac OS expert to resolve that problem.
Yeah, you can remove files from your quarantine.
Right. You can. Right. So now we have this native application, right? What it is, let me show you. It's just this a few megabytes of in size, right? This is like what, 60. Very good. We can compress it later. And there's new time utility, just to show you the difference running it as a Java application and running it as the native image. So my GNU time utility here, when it will run, right, it will print me a number of stats. So to run this Java version of this application, it takes almost 3 seconds, and it takes 350 megabytes of RAM. This is the maximum resident set size. This is the total thing, right? So if I do the same for the thing, I think I need the application. I moved it, right? I moved it. That was not smart. Supposed to copy it. Supposed to copy it, right? Time -v application, right? It starts instantly. Doesn't take any time. I mean, it takes a couple of milliseconds, right? And doesn't take any RAM because wait, no such file. Right? Wait. That's why it doesn't RAM. Right. What do I have? Dot application, right? I hope you're following along, because I'm a little bit struggling here with my command line application here, which is weird. Can you hear me still? Am I on?
Yes, you're on, Oleg. The issue is just that the screen is,
right,
like the resolution on the screen is relatively bad. So maybe if you try to do the font even bigger, maybe it somehow can be. But,
right, I am increasing the font more, but yes. My main concern here is that let's do this. Now it's in the middle of my screen. But my main concern here is that my session here just kind of sort of died, right? My main concern is that my session just died here. Dot application, right? So this is it, right? Let's look at the output here, right? So we get no time. We get 20 minutes of the wall clock time. You can see this elapsed wall clock time. And you can see that it took like 50 megabytes of RAM, which some people argue is a little bit too much for the command line application anyway, but it's all in the difference, right? We can optimize it further, but sometimes this is the diminishing returns. So this is how you build a native image. Very simple. Now, there are a couple of things that you need to be aware of when you build a native image, right? One of them is, for example, that you need to have the configuration to assist with configuring native image. Particularly necessary for some parts of the language of your application, which use the dynamic parts. Right? When Thomas showed you the slide, with the analysis where you had the application analyzed statically and run, that analysis is static, right? So some language features require help from the developer, because only you can tell whether you are accessing certain classes through reflection, or whether you are defining some proxies or using other features that will only be available or only be like seen and can be analyzed at runtime, right? So this isn't like this, right? To overcome those, you can provide that configuration manually. It's not actually hard. It's just a JSON file where you need to enumerate what types, what applications, and what classes you are accessing through reflection, or which bits you're accessing through JNI, which resources, like class loader get resources, which things you're accessing, right? But you also can do that automatically. Imagine you have an application like this, which is the reflection example here. I'm gonna go and create this. So I'm gonna go back, and I'm gonna create this reflection example very nicely, right? VI reflection example, Java. Right, this is not the best, but also not the worst, right? Reflection example, and this is a very simple class, right? The main class will take some arguments, and then it will, using the reflection API, access the class comments and access the declared method from that class. Method name is taken from the arguments and pass the input to that method. Right?
Can I make the font bigger?
However,
like
we analyze this class.
Make the font bigger.
Yeah, excellent. This is good. Right.
Yes,
very good.
Better. That's not
so. Right. So now we can see that like it's impossible to statically know whether, for example, the string reverser or the string capitalizer need to be included. Right. So let's see how we can configure that for being used in the GraalVM native images. I'm gonna paste it here. I'm gonna save it. I'm gonna JavaKit because we need the class file, right? GraalVM will operate on the class files. So if this example would be in, say, Kotlin, it would be very similar, right? And you can see that we can, of course, run this. It reverses the string because it finds the string reverser class and the reverse method, and it's very nice. So if we build a native image here, for the example, right, we can build this. And I will not build this because I want to save this time, this minute of this. Actually, this will be faster because it's a single class, but doesn't matter. Then when we're gonna run this, right, it will not find the method, right, because the reflection is not configured. So those two classes, those two small classes, right, that we have, will not be included because nothing uses them. And static analysis can say nothing uses them, I will not include them. So how to do that? You provide the assisted configuration using the native image Java agent, right? I will create the configuration directory here. I have my configuration directory, and then we're going to run my normal Java process using the agent that is the native image agent, right? So this is the thing. And I run my application. You can see that I'm running my application, and I'm using some input there. It all runs, and now what we can do, we can look at the configuration that it created. So the Java agent traced all the invocations through the reflection API, right, and through other means that needs to be configured, and just says in the reflect config in the meta-inf/native image directory, right, it says that we need to include the class string reverser, and we're gonna use the method reverse with the parameter types of a string. Very nice, very nice. And we can also merge the config of multiple runs. So I'm gonna include the config for the string capitalizer as well here. I hope you're following along. Like, I haven't heard anything from Timur, but I hope you, right, no, go back. Now we can build this. Now we can build this. So now we have the configuration for both those things. We're going to build this. It's going to take 30 seconds. Last time it took 30 seconds for me for this. And after that, we'll have the executable, native image executable, that is capable of running code that
Нет, мы все размьючены. Мы размьючены, господа.
Guys, can you hear me?
Все работает.
Oh, Thomas.
Отлично. Thomas, yeah. Oleg is not with us now. And
Actually, I have a question, and probably you can help us with it. Oleg just showed how native image generation works when we have some code that deals with reflection, right? And my question is about what if I don't use reflection, but I use something different like method handle API? Will it work, or?
So it depends. So basic scenarios of method handles work, but not everything at the moment. So this is still an open area where we make sure that all method handle scenarios work. But in the latest Graal release, we could make most of the method handle scenarios work with GraalVM.
And what about var handles?
I don't think they work yet. No. And so yeah. So in general, like one of the things you can do in native image if you have a certain part that doesn't work very well is to use substitutions. So this is how the frameworks are making libraries native image compatible, where they are substituting part of the code with something that is more easier to process by native image. And I mean, the reason why we keep native image that way is that, like, if you would open up all of these, like most of the things that do not work on native image are that things that are like very dynamic in nature. So they would throw in a lot of code. So we could no longer say that we could no longer create such a small executable if you would have to include all these possibilities. And it's really here a trade-off between here the size and footprint and the generality of the approach.
Okay.
And our recommendation generally is to use one of the frameworks, for example, Micronaut or Quarkus or Spring Native. And those frameworks should typically have the facilities in place to configure the app accordingly. And ideally, you should not have to do a lot of extra work apart from using those frameworks. Of course, the problem is that sometimes you have to use another library that's like not part of those frameworks, and that might create issues. But in general, we recommend basically one of the frameworks to be used.
Okay, this makes sense. Well, but you mentioned that well, not always you owe 100% of the code that is going to be generated to native image if you are using some kind of dependency that uses, for example, not reflection, but method handle API, and
yes.
You can even not know anything about this.
Yes. It's true. I mean, it should give you an error. It should give you an error at image generation time. But yeah, it is difficult if you have third-party dependencies that use one of these features. But we are working heavily to support a lot more. We have a patch, for example, from Alibaba for Java serialization, and for to support Java serialization, and we are currently integrating that patch. So like the situation is already a lot better than like 1 year ago. I would estimate it will take another year for like to have here almost all features available. But yeah, I mean, it doesn't mean you cannot use native image. No, it just means that like you can use it mainly only for voice one of those frameworks and the dependencies that those frameworks have sanctioned. And this is why I would recommend native image only for new applications, where you build a new application or a new microservice architecture from scratch, because then you have better control over your dependencies and you can use here one of those frameworks, be it Micronaut, be it Quarkus, be it Spring Native or Helidon. And in such scenarios, we recommend native image. We do not recommend native image for a very old application because it could be a lot of work to make it run on native image.
Well, great news then. If I'm not mistaken, in a year we are going to have a new LTS version of Java, and obviously GraalVM is going to support Java 17, and once Java 17 with GraalVM is going to be available, we will have a full support for native image, like for method handle API. So
yes,
sounds great.
Yes, correct. Oh yeah, so Oleg, are you back by now? I think I see your screen, but I cannot see your picture. Right.
Yeah, I am back, and I've been told that my camera feed has been canceled, and you are looking at the magnificent photo of me, maybe with a carpet in the background, maybe not, because I don't see it myself, but I'm back. So, and I heard the discussion right here. I heard the discussion. Yeah, and those are all good points. There are some more advanced features for the configuration of native image, right? Like Thomas mentioned, the substitutions for the particular code, places in code that currently do not work well on native image, right? But in general, the normal code should work fine, right? It's usually the corner cases where there are some challenges and obstacles, right? There are very many non-trivial, if you think about that, there are very many non-trivial applications that are running as native images, right? The GraalVM distribution is an example of that. The GraalVM compiler is shipped as the shared library built with native image, linked into the hotspot, right? So when I run this Java, right, this is my Java minus version, you'd be surprised, but it actually, well, at this particular one, maybe not, because it doesn't, nothing maybe hits the JIT. But technically, if I run Java, whenever I run Java, there is a piece of code that hits the native image shared library built with native image. And then,
yes,
I've seen the examples
here,
of Java X application for it.
Yes, even here you're gonna hit it. You're gonna hit it in initialization code. Yeah. So because and all of these 5 million lines of code that we maintain on the GraalVM projects, they all run on native image. So
yeah, so it certainly can be done. It certainly can be done. There are a number of applications, the command line applications, right? So I showed you the example before, and hopefully you did this. This example yourself, right? There are like SBT client, thin client that is compiled as a native image. There is the Maven daemon project where the daemon runs as a Java project, but the client runs as the native image for speed up, just to avoid this heavy startup on the very thin computation. There are libraries and people deploy this all over the world. So it does run non-trivial things, right? And it also runs, of course, it also runs now my example here, which kind of sounds a little bit boring compared to the actually compiling the compiler, but it still works, right? So, and we have the I showed you the configuration there, right? So I will show it to you again. I will show it to you again. Oh, look, without the camera, it actually feels so snappy. I jinxed it. So sorry, I jinxed it. Right, like you can look at the configuration yourself there, right? So you can generate the configuration for GraalVM native image automatically. You don't need to mess with it manually. Right? And the reflection and all those things are actually, this is not a big problem, right? This all, it all works. What is a little bit more interesting and something that requires more understanding how GraalVM native images work is the class initialization. So this is one of the areas where I feel people do not understand what it does, right? And because of that, they stumble upon problems that are quite easy to solve, and then because of that, they kind of feel bad about GraalVM native images. So I will try to. This particular example was to show and educate maybe people about the class initialization things. Right. So this is a Java application. So classes that we use, they need to be initialized before they are being used. Right. So initialization of the class, for example, could mean that it needs to run its static initializer. Right. So it needs to initialize its static fields. Right. If you have like a static field somewhere and you assign it to an object, or you do something with it in a class initializer, that code needs to be run right before you can use the class. This is how it works. Now, because native image has two distinct lifecycle phases, right? The building of native image and running the native image, you can do the class initialization at two distinct places, right? At build time or at runtime. So far, very simple, right? And then it gets confusing because some applications and some classes can be initialized in both. Some application classes can be initialized only at runtime, and it makes sense to only initialize them at runtime. For example, if you have instances like, let me show you here where it is, right? If you open files, or you create threads, or you create random instances without the predefined seed, right? And if you initialize them at the build time, you need to create those instances of those classes and objects. They need to be transferred to the runtime, and you cannot serialize like an open file or a running thread. It doesn't make sense, right? Or you don't want to serialize your random instance because it will bake in the certain state, and then it will not be particularly random anymore. So some classes need to be initialized at build time. Some classes need to be initialized at runtime, and some classes can do both. And of course, there are some classes that can do neither, right? Those just don't work. So here's an example. I will copy this, and we will explore this in a second, right? We'll explore it here actually, right? So we have the main class with a method that will call to class A, public static field B, and call the method do it. So class A holds an instance of the class B in a static field. So when we access A, we need to initialize it. We will create new B. Class B holds a static field of the char set. And this is not the default char set. This is an extended version or something like that. Right. So now we have three classes, and in the do it method, we just print out this char set. Right. Let me just show you that this works. Hopefully you're doing this still with me. Right. What we do, I'm going to make a directory. Class init, and I'm gonna go into it. Right, class init, the main Java. Very simple. Paste it. Very good. Save it. Java, main Java. Right, very good. We have this Java main. It runs, right? It prints out the char set name, all good. Now, if we try to build a native image out of this, right, and run it, it should be fast as well. I think it should be fast. It should be like 30 seconds. Right? It will crash while it builds, right? And while you get the proof that it crashes. I will explain this. So by default, the classes are initialized at runtime, right? Because for compatibility reasons, this is for compatibility reasons, and the team thinks that this is a good default strategy to initialize classes at runtime. Classes will be tried to initialize at runtime. So native image will include all the char sets by default into the final binary. Right? So there are the default char sets like UTF-8, but there is no particular char set for name UTF-32LE, Little Indian, I think. Could be anything. Could be anything, but I hope it's Little Indian, right? So when we're gonna initialize this class at runtime where there is no char set by this name, it will crash with the unsupported char set exception UTF thing, because the char set is not included by default. Of course, one way to resolve that would be to add all char sets. Right? With this particular option, we can add all the char sets, and this problem will go away. But this is a correct but boring solution because it doesn't teach us anything about the class initialization. So in real life, do this, right? But for our experiments, don't do this. Right? So what we can do, we can print the class initialization strategy, and this is one of the tools to debug what native image is doing. There are plenty of those parameters that you can use to trace class initialization and to print class initialization. They all do different things. So when you stumble upon issues with the class initialization, be sure to read the documentation, right? Or join the community Slack and ask your questions there. But we can do this. We can do this. Let me see what's the situation. Yes, we run it. It breaks. All good, right? So here, let me run this. It will take half a minute as well. But while this builds, I will still continue talking. Right? It prints the initialization configuration to those classes, to those text files. And then it continues with the build, right? And you can see there are different strategies of the classes that are printed out. So there is a build time initialization. There is some initialization that is needed to be rerun, and there is the initialization that is deferred until runtime. So we're gonna look at this file for the runtime. You can see there are our classes A and B. You also can see some classes like those two, for example, right? And it makes a lot of sense, right? Those classes are responsible for getting the limits from the containers, right? How much CPU is available, how much memory is available, right? It doesn't make sense to run them or initialize them at build time because I'm building maybe in a different environment, maybe certainly not in the Docker container. So this is maybe not. This is like it makes a lot of sense that this is initialized at runtime. So those two classes are initialized at runtime. What I can do, I can tell my native image that I want to initialize both at the build time, right? And just like that, my problem will go away, right? Why this is happening? Because when I initialize the classes at build time, the build time is a normal Java process that processes our application. So obviously all the char sets available to the Java process are available at build time. What we can do, we initialize the classes, we put the objects into the static fields, and you can sort of have a feeling how the initialization strategy needs to propagate through the static fields, right? Because classes access other classes to write them into the static fields. So if you initialize something at build time, some other things might also need to be initialized at build time, and vice versa, right? So now I can run this. No problem. Right? And our char set has been created, has been written out and added to the executable, and it works no problem. Right? The rest of the code here, if you're following this, adds in the opposite example, right? We add a thread that will do nothing, but we initialize that in a static block. So our A class will hold the B that needs to be initialized at build time, and it also will hold the thread that is also running. So class A will not be able to be initialized at the build time, right? Because thread cannot be initialized at build time. Because an instance of a running thread cannot be preserved between the build time and the runtime, right? So the solution there will be to initialize at build time only the B class, and then it will work, and it will work the same way as you expect, right? So all very good. right? The reason for this exercise was to show that there are two times or two distinct phases of the life cycle where classes can be initialized, and you need to know about that to effectively use native image, because if you don't know that, there could be some problems and you will be lost. So you need to know about this, and when you know about this, it's fairly simple. Right. How are we doing? Is anyone actually, do we have any note from the chat? Is anyone actually following this? Like, is anyone actually doing the things? Timur, can you give us a hint? Right. I will go further. We don't have a lot of time for
Oleg,
this
can you hear me?
until the first part.
Okay.
Yeah, I can hear you.
Okay, then go ahead, and probably we will have some questions once we will cover the next part of the workshop.
Right. Excellent. So this next part, what I want to do, right now we know most of the things that we need to build the native image, right? Because we can configure the reflection and JNI and the resources, no problem. And now we know enough about the build and runtime initialization to navigate those issues as well. This actually gives you almost the whole tool chain, all the tools in the tool belt, so to speak, to turn your applications into native images without problems. The one advanced concept that is still not covered here is the substitutions. But as Thomas mentioned, right, this is not something that we would like to popularize very much, because we would like to limit their use in the wild. There are some talks about that, but yeah, don't do this for like random reasons, right? Like, be sure that you actually have a good reason for using that API. Right, so now we can build the native image, explore what we can do with that native image, and maybe can we make it better or more suitable for our deployments, right? So I will go back to my application there. Oh, I actually want to go back to the application. I will create a new application. Look at that. Just look at that. I will create a web application using Micronaut as well. And it also will do the prime numbers, but it will respond to the web traffic. And this will be our application that we're gonna utilize across all other tasks in this workshop, right? So Micronaut, we create the thing, we go into the thing, and it's very easy, right? And then we use this file, we create a controller. See, we won't even look what this application, what this project does. We will just know that it's a default Micronaut application, and we will create a controller instance, and we will put it into the predefined place, right? Convention over configuration. Convention over configuration. Come on, save the file. Save the file. Save the file. Save the file. Please save the file. Right, we save the file, and this controller does the same thing, right? We register a few URL handlers that will, when we accept HTTP traffic, we will route the queries to those URLs to certain methods, right? So for example, a random with an upper bound will route it here. And then we will do the same prime sequence, which is the same code that we used in the other app, which will compute is prime, and so on. Very simple, numbers all the way. We can build this app now, and we can run it. We can build it, and we can run it. We can build it, and we can run it. By the way, if you use GraalVM, Gradle runs faster. I'm not sure how much faster, but I'm pretty sure that it is faster. So I'm going to run this Java application now here, because it's compiled, and I will use it, and I will open it in the browser, right? what was that? Bench 8080 primes random 100. And you can see in a nice zoomed in window, we see the same numbers because we still bake in the random number. Right? This is the random seed is pre-baked. So this is always the numbers that it responds with, right? I get those prime numbers, and they're all supposed to be the prime numbers. And if I do another thing, if I like hit a larger thing, right, it will print me more numbers because the actual bounds of the sequence are random numbers between 0, like 2 actually, and this upper bound that we specify. Excellent, right? So our application works, and what we can do further, we can also build a native image out of it, right? And I will do that as well. I will do that in no time, right? This is very simple. I love working with Micronaut here because it just hit native image and it runs. If you are using macOS or Windows, it might be advisable that you actually build your application, build your native image in a Docker environment. Specifically, why? Because if you want to deploy it to a Docker environment, right? If you want to use it in Linux, you want to build it on Linux because there is currently no cross-compilation support, which is something that we probably would like to add eventually. But there are some technical difficulties about this. Namely that, for example, some code from the OpenJDK distribution, right, the implementation of the native methods is linked from the Gravim distribution that is being used. So if you're building on macOS, some macOS specific code is getting into the native image. So an implementation for Linux could be different, and it could just not work in this. So we need to finish this in just a little bit. I'm not sure how many minutes do we have, like 6 minutes probably. We have 6 minutes, and this will be enough to finish this exercise. And I want to show you this very nice utility called UPX, which is Universal Packager for Executables. And it's not ours, right? This is a random utility on the vast fields of the internet that you can get. So no promises there. But what UPX does, it can compress your executable into a smaller executable. It's sort of zips it, right? It compresses it, and then the executable is smaller, right? So I showed you a small Micronaut application, and it was what, like 60 or 70 megabytes large. This one will also be like something like 70 megabytes large, hopefully, maybe larger, but hopefully around 70, 80, right? And this is a little bit too large sometimes, because one of the for the native image that people use it very much is the serverless framework like AWS Lambda. And normally they have the limit at something like 200 megabytes for the archive. So if you use a very large application, right? If you have a very large application and you build it into native image, it might not fit into that under that limit, though it's supposed to be like a very application, right? But allegedly people hit that sometimes, right? So our small application here is 74 megabytes, and you need to understand, like, think about that. It includes all the infrastructure, right? It includes Netty, it includes all the Micronaut, it includes all the routing code, it includes everything. So if you add a few classes here and there, or a few libraries in, like, the size will not grow as dramatically as here. But what I can do with UPX, right? I can specify the compression thing here. So I will do exactly that. So what I need to do, my UPX is actually there in home, right? UPX. And I just download the UPX there. UPX. Am I dropped? Did I do something inappropriate?
No, I just want to say that we have only 2 minutes till the end, the time slot. So can we stop in this moment and to continue in another part, the second one?
Yeah, we have 2 minutes. Look, this is just in time execution of the particular tasks. Right. No. We're gonna stop in a minute, but I just want to show you how well it, right? Because 74 megabytes is not something that you will be proud when it's to your friends who are writing Go code something, right? They will be like, oh, 74 megabytes, it's like too large. So they just give it a few seconds. Look, it's compressing. I know that we're on the clock here, but it's compressing, and I don't even do anything anymore. It will finish compressing any minute now. Any minute.
Okay, while it's compressing, I encourage every participant of the chat to ask questions even during the break, and we will cover all the questions in the second part of the talk.
So thank you guys for the first part. I guess it was really interesting for our audience. If you have any questions, guys, welcome to the Telegram chat. You can ask any question who follow the workshop or just listening. And see you soon in 7 p.m.